How tunnels underwater don't leak, engineering genius. Have you ever wondered how underwater tunnels, massive structures stretching beneath rivers, lakes, and even oceans, manage to stay dry despite the crushing weight of water above them? It sounds almost magical, but it's pure engineering brilliance. From the Channel Tunnel connecting England and France to the immersed tube tunnels of Japan and China, these marvels of modern infrastructure operate in one of the most hostile environments on Earth, underwater, and yet they rarely leak. So how is this possible? The secret lies in meticulous planning, precision construction, and advanced waterproofing techniques. Building an underwater tunnel isn't like digging a hole in the ground. First, engineers must study the soil and rock beneath the waterbed, using sonar, boreholes, and 3D mapping to decide the safest route. Depending on the depth, location, and purpose of the tunnel, engineers choose one of three primary construction methods: boring, using a tunnel boring machine; cut and cover, dig, build, and bury; or immersed tube, sink pre-built segments into a dredged trench. Among these, immersed tube tunnels are especially interesting. Here, giant tunnel segments, sometimes as long as football fields, are constructed in dry docks, made watertight with rubber gaskets and steel joints, and then carefully floated to the site. Once in place, they're sunk into a prepared trench under the seabed and joined together with extreme precision. A critical part of this process is sealing. Flexible rubber gaskets and watertight joints ensure that not even a drop of water enters. These joints are pressure tested to withstand not just water but tidal movements and seismic activity. In bored tunnels, like the famous Channel Tunnel, or Chunnel, engineers use enormous machines called TBMs, tunnel boring machines, that carve through the ground while installing reinforced concrete linings behind them. These linings are made of precast concrete segments, locked together with waterproof gaskets and sealants. Each ring is tested for fit and water resistance, and grout is pumped between the tunnel and surrounding earth to add another layer of protection. Even a minor gap is unacceptable. Any leak could spell disaster. To ensure long-term safety, sensors monitor pressure, humidity, and structural integrity 24/7. But it's not just about barriers, materials matter. Concrete used in underwater tunnels often includes additives to prevent water infiltration, resist corrosion, and even self-heal tiny cracks over time. Engineers also add waterproof membranes and layers of special coatings to fight long-term wear from saltwater. Redundant drainage systems carry away any condensation or seepage, which is rare but anticipated in the design. One of the most ingenious aspects is pressure balance. In deep tunnels, air pressure inside the tunnel is controlled during construction to match the external pressure from the water and soil. This prevents sudden bursts or leaks as crews work. And when the tunnel is completed, its design ensures that the pressure outside never overwhelms the internal structure. The precision required is mind-blowing. Even a single misaligned segment, a weak joint, or a poor quality material could lead to catastrophic flooding. That's why these projects take years of planning, testing, and perfect execution. Engineers must also think long-term. What if there's an earthquake or rising sea levels in 50 years? Tunnels are built with expansion joints, shock-absorbing features, and access points for maintenance decades into the future. All this engineering doesn't just keep the tunnel dry, it keeps people safe. Millions of commuters, freight trains, and vehicles pass through these underwater pathways every day without even realizing the genius working silently around them. So next time you're in a tunnel under a river or sea, remember, above your head is possibly hundreds of tons of water, but you're safe, dry, and moving thanks to a perfect blend of science, math, and human ingenuity. Underwater tunnels aren't just holes through the ground. They're proof that with the right design and relentless precision, even the deep sea can be tamed. Like and subscribe.